Read carefully. A resourceful home decorator manufactures two types of lamp, A and B. A home decorator manufactures two lamps, A and B, and go through the two technique. When he will prepare a lamp, he have to go to the two technique. First is cutter and second is finisher. To produce lamp A require 2 hours of cutter time and 1 hours of finisher time. Similarly, lamp B require 1 hour of cutter time and 2 hours of finishing time. To produce a two lamp, this is the constraint. Also, we have given the cutter has 104 hours and finisher 60 hours of time available for each month. Means when the home decorator want to produce lamp A and lamp B, he must use 104 hours for cutting and 76 hours for finishing. And the profit on lamp A is rupees 6 per lamp. Means A lamp having the profit is per lamp is rupees 6 and for B lamp it is 11 rupees. Assuming that also he can sell that he can produce. Then we have the question, how many of each type of lamp should he prepare to obtain the best return? How many each type of lamp should he prepare? Therefore, first we start with the decision variable, and therefore let x1 be the number of lamp of type A. He produce x1 lamp of type A. Similarly, x2 lamp of type B. We have given that the profit per unit per lamp is rupees 6 for lamp A and for lamp B it is rupees 11. Therefore, our total profit is 6x1 plus 11x2 because we have prepared the x1 number of lamps of type A and x2 number of lamps of type B. Therefore, the total profit must be 6 into x1 plus 11 into x2. We have given the total cutting time is 104 hours per month and lamp A require cutting time is total 104 hour and lamp A require 2 hours for cutting and 1 hour for lamp B. Therefore, the constant is 2x1 plus x2 less than or equal to 104 because we have the total cutting time is 104 hours in the month. Similarly, finishing time is 76 hours per month and lamp A require for finishing time is 1 hour and finishing time for lamp B is 2 hours. Therefore, the constant is x1 plus 2x2 because finishing time for lamp A is x1 and finishing time for lamp x2 is 2 hours, but total finishing time available for each month is 76. Therefore, the second constant is x1 plus 2x2 less than or equal to 76. And hence, our LPP becomes maximize Z because profit is maximized. Therefore, it is maximize Z equal to, we have to prepare x1 lamp and profit per unit x1 is rupees 6, therefore it is 6x1, and on lamp x2 is 11, therefore objective is maximize z, 6x1 plus 11x2 total profit. And subject to means restriction, first is restriction is 2x1 plus x2 is less than or equal to 104, and second constraint is x1 plus 2x2 less than or equal to 76. Suppose we want to convert the given LPP in the standard form, then it becomes maximize z equal to 6x1 plus 11x2. Here all variables are non-negative. Subject to 2x1 plus x2 less than or equal to constant, so we add the slack variable, it becomes converted into equality. Next is x1 plus 2x2 plus new variable again x4, which is also slack variable, 76. All x1, x2, x3 and x4 are greater than or equal to 0. This is our standard form of given LPP. See, this is our standard form. Let us see the third example. We have given that a farm produces three types of cloth, cloth A, cloth B, cloth C, and 3 kinds of wool are required for it. Means to manufacture 3 types of cloth, it requires 3 types of wool, say red, green and blue. 1 unit length of type A cloth need 2 yards of red wool. For 1 unit length of type A, to prepare 1 unit of length of type A cloth, it required 2 yards of red wool, 3 yards of blue wool, and 1 unit length of type B cloth. Means to prepare a type B cloth, it required 3 yards of red wool, 2 yards of green wool and 2 yards of blue wool. Similarly, for type C cloth, need 5 yards of green wool and 4 yards of blue wool. No need to prepare the C type of cloth, it does not use red wool. The farm has only stock of 8 yards of red wool, 10 yards of green wool and 15 yards of blue wool. It is assumed that this is the constant. It is assumed that the income obtained from 1 unit length of type A cloth is rupees 3. Means to prepare 1 unit length of type A cloth, the profit per unit is rupees 3 for cloth A, rupees 5 for cloth B and rupees 4 for cloth C. We have to determine how the farm should be use the available material so as to maximize his income from finished cloth. Let us see the formation. We have asked that how the farm should be used the available material. First we consider the decision variable. Suppose x1 be the number of unit of cloth of type A cloth. Similarly, x2 be the number of unit of cloth of type B, and x3 be the number of unit of cloth of type C. These x1, x2, x3 are the decision variable. Next, the profit for type A cloth is rupees 3. For type B cloth is rupees 5 and C is rupees 4. Therefore, our objective function total profit is equal to 3 into x1 plus 5 into x2 plus 4 into x3. But profit must be having aim to maximize. Therefore, our objective function is maximize z equal to 3x1 plus 5x2 plus 4x3. Now, let us see the constant. We have given that to prepare 1 unit length of type A cloth, it required 2 yard of red wool, 3 yard of blue wool and 1 yard of green wool. Therefore, the total red wool available is 8. Total green wool available is 10 yard and total blue wool available in the farm is 15. Therefore, the constraints are 2x1 plus 3x2 because type A cloth does not use the third wool. Therefore, it is 2x1 plus 3x2 less than or equal to 8 and 2x2 plus 5x3 less than or equal to 10. C. 10 yards of green wool and 15 yards of blue wool. But to prepare the cloth A, it required only red wool and blue wool. Red wool and blue wool. Therefore, we use 2x1 plus 3x2 less than or equal to 8, 2x2 plus 5x3 less than or equal to 10, 3x1 plus 2x2 plus 4x3 less than or equal to 15, and we can convert this LPP into standard form using slack and surplus variable. But inequality, all inequalities are less than or equal to type. Therefore, we use only slack variable. Therefore, it becomes 2x1 plus 3x2 plus x4 is equal to 8. Next, 2x2 plus 5x3 plus x5 is equal to 10, and last one is 3x1. Last one is 3x1 plus 2x2 plus 4x3 plus x6 is equal to 15. All the variables are greater than or equal to 6. I is from 1 to 6. Thank you. Any question?